My name is Luigi Silipo, and during this webinar, we will go through an engineering to order process, and we will see an idea of a best practice scenario on how to get from a sales quotation for a product which is tailored directly on the customer needs up to the manufacturing. During the presentation, we will follow up an idea first of a full system landscape. So what would be actually an ideal scenario for BEAS and additional systems like PDM or CAD, which is actually included in your customer's landscape. A typical combination of functions, which will be managed or could be managed by the ERP and BEAS. An example of the product structure, which will be actually manufacturing during the webinar, and finally an example of the process. So let's start from a typical system landscape. A typical system landscape actually sees SAP Business One and BEAS manufacturing as the center, of course, of the entire system landscape of your potential customer, with the PDM and CAD system, which might actually produce product management and BOM import files for the ERP, quality management system, and machine data collection. All of these actually will be flown into the BEAS integration app, which is ready to actually read and write into the system any information that we want to acquire from third-party systems. Typical combination of functions would include actually in the product management flow, BOM management, external operations management, data integration interface as we have just described, and the calculation, which is a key functionality in, of course, engineering to order process. All of these could be actually backed up by version control, which is fully integrated into BEAS. Of course, in the material management business process flow, we will have material disposition, goods receipt, and eventually quality control and release of batch controlled items or for any item. The manufacturing management, which will go through manufacturing planning, forecast planning, eventually material reservations, product release. The internal manufacturing, which is backed up by quality control as well. External manufacturing by external suppliers, and finally, quality control and release of batches. And finally, the service management, which for this business process is actually maybe not relevant. Let's see the idea of the product structure for this engineered to manufacturing item. The product we're going to simulate today is going to be an example of a bike. This is for a bike manufacturer. The product is going to be built initially from a template dummy, which is basically an idea, as I said, of business process, which might speed up also your customer's business process, allowing the people in sales to basically define a product based on the customer needs and with the backup of engineering in order to define the idea of the product structure and provide a quotation to the customer. The finished product that we will then obtain after the engineering will be, of course, the final bike, which has been actually manufactured with two sub-assemblies, the front and the rear wheel, and then we will have, of course, the frame, the handlebars, and the seat. And all of these sub-assemblies and the final assembly will have, of course, an assembly operation which needs to be carried out in a manufacturing plant in order to get the final bike. One interesting thing that we will note is that the semi-finished product, considering here that the entire structure is engineered to order, these two semi-finished products will be order related. So this means that when the system will generate the manufacturing order for the finished product, will automatically generate also the manufacturing orders for the sub-assemblies. And when we will plan in APS the finished product, the system will actually take into account also the manufacturing and the planning of the two sub-assemblies and all the related items. Of course, as I said, this is a scenario imagined for individual products for one single customer. So basically, we could be starting from any existing product or actually even from a non-existing master data, like in this example. We will have a calculation based on template on dummy item for, as I said, quick input during the sales process. Then we will simulate the import of BOM positions for the same finished product which could be coming from a third-party system, as a CAD system, a PDM, or anything. And eventually, this functionality can be extended also when the work order is already existing. So we could have actually the work order growing as soon as the engineering is completing the definition of the entire product structure. Then we will get to procurement or purchase item based via MRP and APS, as I said. The next slide is showing an idea of the entire business process. We will start, as I said, from sales offer. We will make a calculation over the sales offer. We will finally get to define a sales order, and eventually we can do an additional calculation on the sales order just for, being fully 100% compliant that the product structure is compliant to the customer needs. We could still apply some changes up to the sales order level. And once engineering is finished, the entire product definition at the level of the sales order, we will have the definition of the work order, and the creation of the work order. As you can see here from the engineering, I've traced down to dotted lines because actually in BEAS it is possible to retrieve back the result of engineering directly over the sales order and then create the work order from the sales order, or we could actually just create the work order directly from a structure which is being engineered by our colleagues. Okay, as I said, then we will go into production planning and scheduling with the planning of the finished product, material requirements, and purchasing. You see I've drawn a red line here because for timing reason, I have the feeling that we will get up to that point of the business process. All that is actually below that line belongs to quality control and manufacturing management, which is actually a process common to other kind of manufacturing. It's not only specific to engineering to order, but it's basically common to any other manufacturing process. So what is important for us is to get the work order for the finished product exactly as we have engineered it. Okay, I will jump into the system now. That's my SAP Business One. You can see it open in the desktop. We will start from the sales quotation. So starting from the sales quotation, basically that's a standard, of course, functionality of SAP Business One. First thing we're going to do is actually select our customer and set a validity date for our quotation, and then start from a dummy item. Now, in our quotation, we could actually just change any description here. And accept it. We will add our quotation just with no price and basic line into it. Then we will get back into it, and by right-clicking over the quotation line, we will have this function, which is actually a BEAS functionality for inserting a new calculation. Now, the calculation functionality of BEAS is actually extremely flexible and built for such cases of engineering to order, and it's based also on calculation schemas. Now, you will see an example of my calculation schema, which is basically we'll start evaluating the entire product structure based on, of course, the direct material costs, direct labor costs, and then we will have some additional surcharges which will be applied by the calculation schema up to the point where we can get actually into consideration the profit margin we want to apply and eventually the discount we might be willing to concede to the customer in order to get a final sales price. In the pre-calculation module, which is the one we're looking at, as I said, we have total flexibility. So basically, at this line, we could start inserting the ideal positions that are going to be basically the base for our finished product. And this job could actually be carried out directly by one single person, or could be carried out by several departments of your end customer company. Okay, let's assume that we're going to insert first a new assembly. As you can see, the insertion I'm doing now for this new item is based on something which is not existing. So it's a master data which we are just defining at the level of the pre-calculation. What we're going to define as a first subassembly is going to be, for example, our rear wheel. So we're just going to name the subassembly. We will obtain a position now here, which is going to be the rear wheel. And now by clicking the new button below, when this line is highlighted, the system will insert automatically a new purchase item in that subassembly product structure. So the first item we're going to insert is going to be our wheel rim. And at this stage, it's not really important any other information other than a possible purchase price. So we're going to insert a purchase price of 15 euros for the wheel. Again, we're going to place ourselves with the cursor on the first subassembly line, insert a new one. System is going to insert a second purchase position. This one is going to be for the spokes, and the price for the spokes will be 7 euros. And we're going to update again. Please note that while we are inserting these lines inside the pre-calculation, our calculation schema is already applying all the logic for calculating the finished product price, and it's replying in real time with the actual product price with the structure we are inserting. So now we're going to insert the third purchase item, which is going to be our tire for the rear wheel, and this tire is going to have a price of 4.5 euros. Finally, by selecting the top assembly again, top subassembly, we're going to imagine that we will have an assembly operation at this stage. So we're going to select one of our existing work faces, and we're going to just input a description for the operation and an estimated time of processing, which is going to be, in this case, for example, 90 minutes. Okay, that's our first subassembly. At this stage, we will move again on the top level product, right-click, and insert a second assembly. This time, this is going to be the front wheel. And now we're going to work on the second subassembly. So by having this line selected, we will click the new button and we will insert the products that we need for the front wheel. So again, it's another wheel here, which is going to cost 15 euros. We're going to insert a second line, which is going to be the spokes again. And the price for the spokes is going to be 7 euros. Again, for the front wheel, selecting the assembly, we will insert another item. It's going to be a tire. And the tire is going to cost 4.5 euros again. And okay, because actually on this bike, on the rear wheel, we want to place a clutch and also, of course, give an optional to our customer. So we're going to insert an 11 times cassette. And price of this is going to be 9 euros. So we got basically the rear wheel complete. The front wheel just needs now the assembly operation. And again, we're going to select same work face, same work center. And we're going to describe the operation. And input a time into this. Okay, so now we got the two sub-assemblies defined, front wheel and rear wheel. at the level of the top product, we're going to add some additional materials which will need to be assembled together with the front wheel and rear wheel in order to obtain our finished product. And so we will imagine to have a frame for this bike. And the frame is going to cost something like 60 euros. And then we're going to have another couple of purchase parts, which are going to be handlebars with a price of 3 euros each, but for the handlebars, we need a couple of them. So we have updated the quantity. And finally, we need a seat for our bike. And the seat is going to cost 21 euros. Finally, on the finished product, we need an operation for the final assembly. Again, we select an operation, insert a description, and insert a timing for the operation as well. Now, the system is returning all the info that we need at this stage in order to get a quotation for our end customer. In this case, we got to a sales price, which is actually going to be around 485 euros. What actually we could do here is also, for example, we want to offer an alternative for the frame for our customer, and we could insert also an option, for example, a frame in carbon, which is going to cost a bit more than the aluminum one. And once we do this, we could say for this line that this is optional. And please note that while we select the line as optional, the price will not change. While when I revert this line to normal status, the price will be updated accordingly. Of course, in this case, we're not going to give two different frames at the same time to our customer. So we're going to leave the frame as an option, the carbon one as an option for our customer. Also, at this level, any change of the structure is allowed. So we could actually just drag and drop any of these lines in order to have our product structure to be expressed by the system in a proper way. Like we want our front wheel here, and we want our rear wheel as well at the level of the top product, and then we want all our purchase items and the final assembly. So once we get to the defined final product structure, we are ready actually to supply a quotation to our customer. There is one last thing which is extremely important in this case, that we are actually working with the calculation schema, which has been called up during the first pre-calculation entry of the functionality. But at any time, we could change the calculation schema and have the system recalculate this entire product structure based on a different calculation schema that we have previously stored into the system. Once we're finished and we have defined the finished product structure, we can set to return back to the document, and the system will ask if we want to pass this price as a sales price in our sales document. By replying yes, of course, we will have now the sales document in SAP Business One updated with the price of the product that we have defined. Of course, at this stage now, it will be a matter of just presenting the quote to the customer, discussing it, and having it approved by the customer as well. The next step, according to the business process that we have described, is going to be actually to create the sales order after our calculation. So by using a standard SAP functionality, we will copy our sales quotation to sales order. And the first thing we're going to do is actually select a possible delivery date which is the delivery date that our customer is requesting. Now, in the business process, we are imagining, and I'm reverting back to the business process slides, we have had engineering, which has been involved throughout the time since the sales offer up to the sales order definition for creating the correct product structure. We have assumed that this item that we have used for the initial quotation is going to be a dummy item. So at the level of the sales order, we will just change the description. That's dummy item not to use. We will zero out the unit price. And we will now leverage what engineering has been doing for us. In this case, we're going to assume that we have received the full product structure from our engineering department. But as I will demonstrate now, I am saving the order. At this stage, actually, when we create a new calculation, we could have the possibility of importing directly from a text file which has been built by our colleagues in engineering. And you can see these text files have been created as simple text files with tab delimiting, with tab delimiter separator, and they're just reporting the basically the product structure, the materials, and anything we need. So let's assume, for example, that we want to delete this subassembly and we want to import it. The system will just create the structure of the subassembly at this level, and we can just, recreate it in a proper way. Actually, sorry, this is not what we want to do. We could actually have our subassembly for the front wheel. Created, and when we have this line highlighted for this subassembly, when we will import the subassembly structure, the system will automatically insert it at that subassembly level, and what will be left for us is actually either completing it with the operation sequences that we need to create, or we could receive directly into the text file, we could receive the entire product structure, which is built by purchase items and also by the entire routing and operations that we need to perform for manufacturing the item. I will not save the calculation now because we have already the master data created, so I will just cancel and get back into our calculation again. What we're going to do, though, this time is that we're going to substitute as a final touch for the sales order, because the customer in the meanwhile has decided that he wants to go for the option. So we will substitute the frame from standard aluminum. We will delete it. And we will decide that we want to insert an item. You can see with this option here, insert item, what the system will do is slightly different from what we have demonstrated up to now, because the system will now present the list of the items which are existing into the system. So this means that in the meanwhile, engineering has been working on the definition of our products and of our structure, and we are now bringing into the product structure our option. We're moving it at the right level. What is important also is that the system has captured now the price that originally was inserted by the system for that product structure defined with the aluminum frame. And what we are seeing now is that we're going to get a price which is going to be 518 euros, which is slightly different from the previous one. So we're going to actually change the value here to 520 euros, for example. We also know that we can reserve up to a discount up to 3%. So once we change this at this level to 520 euros. When we update and we click over OK, the system is actually noticing that the price is different from what it was originally coming from the sales document line. And if we click on a yes, we're going to get the new price at this level. Actually, now we could even be applying our 3% discount in order to stay in line with the calculation we have performed. Okay, so this is basically the entire part of the, let's say, engineering to order processing. What is interesting now, once the sales order is defined and the product structure has been completed, what is interesting, of course, now is that we want to create now the manufacturing order for our product. So for creating a manufacturing order in BEAS, which is strictly related to the sales order, we have an option directly available on the sales order screen. By right-clicking, you will see that the system will propose the work order creation function, which is a new work order for finished product 001 at line 2, quantity of 1 piece. Or the exact same functionality, we could have it from the production menu, sales order to production order. This will bring up to screen all the sales order lines which still which have a product which is order related and still have to be sent down to manufacturing into a manufacturing order. What we will do now is create the manufacturing order by using the functionality directly on the sales order line. Now that the work order is created, we get a green bar message here in the SAP Business One status message bar. And by right-clicking again, either on the order header or on the order line, we will see that we have a work order created. Now you will see it with the green icon. And we could eventually directly edit our work order and see how the system has created the product structure. One thing that I want to point out is that, of course, the system has been using the calculation structure, which is associated to the sales order line, and has received, of course, the frame carbon as a material that we want to offer to our customer in the manufacturing of this bike. Now, in this case, the bike is also a serial number managed item, so the system has reserved the serial number which will be received at the end of the manufacturing process. Also, for the front wheel and the rear wheel, as I said, because these are order-related subassemblies, the system has created directly into the finished product work order structure the substructures for manufacturing the two assemblies. Now, this is gonna be important for the APS scheduling functionalities that we're going to see now. Let's note that for the finished product, we have obtained by the system a delivery date which is for the 27th of June. That's because by our system parameters, manufacturing is going to be completed a couple of days before the delivery date, which has been requested by the sales order. Now, in order to get into the APS, we will go through capacity planning. That's menu in the submenu in the production main menu. We will open up APS. And in the APS scheduling, what we have defined here are two main scenarios for basically scheduling our manufacturing orders. Now, in BEAS, APS is basically fully customizable up to let's say an extreme extent where you can define anything like the way the APS should present your manufacturing orders, if it has to hide or not hide specific orders, if you want a sorting which is based on anything like a name or an SQL statement. At the resources level, you could automatically include or exclude resources. At views level, you will have the possibility to define specific views for that APS scenario. And by clicking Edit, you will see that you can actually define any view or subview and field descriptions by SQL statement or any other means that are appropriate, and calculation types also associated to that scenario. Calculation types are separately defined by this specific menu item in Capacity Planning APS calculation types. And the calculation types are the real, let's say, the real heart of APS, just because in each of these single lines that you're seeing here, there is basically the APS planning logic. Anything that you see in the options that I'm showing here is basically determining how the system will calculate reset dates and basically use the capacity of the machines, which is going to be interested by a specific manufacturing order. In our scenario specifically, we have assigned these 6 APS calculation types, and we will see basically the forward scheduling. As an information for you, when a work order is created, there's a standard in Topeas, the system backwards schedules the work order from the delivery date up to, of course, back, and will calculate the duration of the operations and the materials requirement time based on the backward scheduling of the single operations. Now let's get into APS. So we, again, open the Capacity Planning APS. We will get into the standard scenario, and we will click View in order to get an overview of all the manufacturing orders, which still need to get worked out by APS and scheduled accordingly. Now, what we will do is we will filter by resource. Of course, this is a work which is required by a specific department of your customer's company. A planner is required here. In our example, we're going to select our machine, our department actually, which is the assembly department. And we see our finished product work order we just created, which is standing here and waiting to be scheduled. Of course, we could access directly the work order by clicking on the yellow arrow, and we will be brought into the product structure, which we have seen a few minutes before. And by selecting several options on this screen, we can have different behaviors, of course. Now you see the calculation types which have been assigned to this scenario are all selectable in this top drop-down box. And for example, we want to start with a forward scheduling. And this forward scheduling will also take into account material times and material availability. In order to run a correct forward scheduling, what we will do for this specific manufacturing order is to set the start date we would like to define for our finished product. And we could say, for example, as a first attempt, we would like to start 21st of May. As soon as I set my start structure, the system will, of course, delete the start time and end time and will wait for me to calculate. When I click the calculate button, all the orders which have been selected by this tick box will be automatically calculated by the system. Now, for our order in a specific, we are seeing that we're having a problem in delivering on the 27th of June, just because by starting, even if we start today, we will have a problem. We will have several problems. First of all, we can see in the start structure that we could start on the 7th of June. What does these fields mean? And what does start structure mean? Start structure means that the lower levels of our manufacturing order could actually be started on the 7th of June. But we have a problem specifically for one material which cannot be received earlier on than the 28th of June. So now we can check what is happening at this point, and by right-clicking over the line, we can have our shortage info, which is being brought up by the system. The shortage info will show us for each level of our manufacturing product structure, so any lower level of the finished product, that we need to get into stock all these materials, and specifically, we will have a problem for this one, which has a lead time of 30 days. That's our famous carbon frame, as a delivery lead time of 30 days. And so the first date of receipt can be actually 28th of June. And also these are the two materials can be delivered not earlier than the 12th or the 14th of June. So basically, assuming that we have got this reply, we will change again our start structure. And we will say to the system that we can actually start manufacturing on the 28th of June, and we will recalculate accordingly. Now, we probably have solved a problem of material shortage, but in any case, we got a problem in the delivery date, which cannot be, of course, fulfilled anymore. So at this stage, we will have to get into our sales order or inform our sales department by either a mean of a query or an alert function that the delivery date will have to be basically postponed of a few days. Let's say, for example, we want to deliver 1 week later. We're going to deliver on 3rd. Sorry, not August, but in July, on the 6th of July. Okay, once this operation has been, of course, completed, we are now ready to run through MRP. So what we will do, we will call up the functionality of the MRP wizard. MRP wizard is based as well, like APS, is based on basically scenarios which are defined at the system level in this screen. We'll just have a quick look at the scenario we have defined here. And our scenario is basically taking into account several bagging and replenishment originators. And specifically, I want to point out that in sales, we could have this checkbox ticked, which is considered calculation. Now, in our example, we've been going through a process where engineering has been taking care of creating the master data and actually providing to sales a full product structure, which has been fulfilled into the system. So we have, of course, all the master data created and the items which have been namely defined into the product structure. But if we did not create the master data and just left the customized product structure at the level of the sales order calculation, providing that those items are existing as master data into SAP Business One and BEAS, the system could have planned directly the calculation structure, which is linked to our sales order. Now, I will quickly run an MRP calculation. And we will get now our order recommendations. Now, the system will present, of course, a full list of items, but in order to make our job slightly easier, we could filter by work order. Now, this is the work order that we have created just earlier on. So by selecting our work order and clicking on OK, we will see all the materials and the finished products related to our work order. In particular, we will see that all the materials, the wheel rim, the spokes, the tires, and everything will have to be purchased. And you can also see that the system has placed the date of purchase, or actually the week of purchase, according to each single material lead time, so that we can optimize actually our purchasing flow and purchasing flow of our customers, so that materials are not actually received into stock earlier than needed. The only exception is our frame carbon, which is actually creating, if we order it today, we're going to receive it on 28th of June. Now, we could actually order specifically by double-clicking on the below part of the screen. We could actually create several purchase orders for each single line. But in order to, stick with the time of our presentation, I will just change the screen to the mode, so that the below part is not shown anymore. And I can click also the pre-assign button. Before doing that, sorry, yeah, well, that's fine, but I will click the pre-assign button, and the system is actually pre-selecting that we want to proceed with the procurement of purchase parts. And if I would actually now just click the pre-assign, the system would only create a purchase order for our frame carbon, which is the only line which actually we need to order this week. So what we can do is we can, let's say, increase our security buffer by a number of workdays and click the pre-assign button. And by doing so, all the lines which are now displayed on screen and our purchasing line will be selected by the system, because we are basically anticipating the purchasing date time. Once this is done, we will click the purchase request button. For each single line the system finds that has a supplier and a price, it will actually create a purchase request into Bayes. Now, this purchase request is ready to be analyzed by our procurement guys and is ready to be actually sent over to a purchase order. So we will create now the purchase order. And with these, basically with these steps, we are now ready to manufacture our product. Now, the flow of manufacturing into Bayes can be done according to several scenarios. Now, getting back to our slides, we should actually be receiving our purchasing, and we could start the production assembly. So I will quickly receive our purchase order, which has just been created. This can be done either via the standard SAP functionality of creating the copy of this purchase order to the goods receipt PO, or we could use the Bayes function, which can also be made available over a terminal and can be used with barcode scanning functionalities for people in the warehouse. So we'll select the first line of our purchase order and we'll add it. Second line, confirm the quantity and add it. Third line again, confirm the quantity, add. Fourth line, confirm quantity and add. And fifth line, the carbon frame. This is a batch managed item, so we will also assign a batch number. And finally, line 6. And our last line, the seat. Once we have completed the checkout of our document and we are receiving the goods, if we click the goods receipt, the system will create a goods receipt into SAP Business One, and our purchase order will be closed and, of course, linked with the standard SAP functionality to the goods receipt. As I said, we're now ready actually to manufacture, and we have several options in Bayes to continue with the manufacturing flow. Basically, we could decide that we provide terminals, as the slides are actually showing here. We would first produce the assembly, then the finished product, and these can be done via, for example, terminals, or can be done via web apps, or could be done by simply a backflashing functionality, which is the one I'm going to show you now. So for the work order backflashing window, what we will do now, we will select basically first one of our sub-assemblies, for example, the first semi-finished product, and confirm completion. And this is going to basically provide into one single operation materials will be used on that work order position, and the finished product will be received. So if I just actually the subassembly will be received. So if I open now my work order, this position will be closed. All materials have been consumed, the product has been received, and the operation has been completed. Okay, I will now stop the webinar, because that's basically the flow for which I had in mind to present for engineering, and I will unmute you so that we can open our question and answer session. In 1 second, I will unmute you all. And please, you can start with your questions, or you can raise your hand and start with the questions. Any questions?
No, for this time. It's good.
Yeah.
No questions at all?
No question.
I have a question. In a production line, how we can see the drawings using paperless?
Using paperless, you can see the drawing.
With papers, sorry.
Yeah, I'll just revert back to our system. Now, when you get to, for example, a work order, you have the possibility of printing the work orders based on a Crystal report template that you have created. Now, this is the standard Crystal report template that you get from BEAS, but this one could be enriched with the drawings or any other information you like, which is coming from the master data or from the manufacturing order. Or if you're working with the pull report, I will show it to you over the terminal. If you're working on the pull report, for example, these are all the operations that you need to carry out now in manufacturing. By double-clicking any of this line, you see that this part of the window is actually ready to show. You see this little camera icon here. This will show any image which has been linked to that specific operation or that work order.
Okay.
Okay, so this can be actually made available directly on the terminal for the workers.
Okay, another question. The bill of material is upgraded by PDM, SolidWorks PDM,
Yes.
automatically. Okay.
I will show you now. When you use the data integration hub, I will show you in the product structure, stock management item structure. Say, for example, these handlebars. In the extended functionality, in the extended tab of the bill of material for that product, you can see that you have an option here for synchronizing. Okay. And when it is set to yes, what this means is that via the Data Hub integration, anything that will be received from the CAD or the PDM will be synchronized with this specific position. So if you have any change in the quantity or anything else that's relevant to manufacturing, this will be brought to.
Okay.
But it's always inserted. You cannot update, right?
You can update and you can also delete the lines.
Are you sure? Because I tried this with Data Integration Hub, and it overwrote the whole bill of materials.
I'm quite confident.
Okay.
I'm quite confident you could, but yeah, I will double check for you. Who's asking the question? You could send me an email, separate email. I didn't realize who was asking the question. Sorry.
Yeah, I came in a little late Can
Is that Paco?
Yeah, that's me.
Yeah, okay, Paco, that's my email. I will type it on the screen. If you send me an email,
Yeah. Okay.
I will
Thank
double
you.
check for you and let you know. Yeah.
Great.
Any other questions? It's a quiet audience.
No, I think that is great software. I will review if we need how many licenses we need, but I understand that for production line we need a particular license, right?
For the terminals, like the one I'm showing you here, for these terminal, you could buy separate licenses, and of course, these licenses are at a lower cost than the full license of the base client. And depending on the functionality you want to activate, you can actually choose if you want just a terminal for manufacturing, or you want it for quality control, or you want it for goods receipts. So you can have basically different functionalities for each license you buy on the terminal.
Okay. Okay, thank you very much.
No problem.
I don't have questions.
Okay, so if there are no additional questions. Yeah.
Luigi?
Here.
Do you hear me?
Hello, that's Fulvio.
Oh, good morning, Luigi. How are you doing?
I'm doing fine. I'm doing fine.
Okay, just a question. I posted it on the chat line, but I guess you won't be able to read it. So the question is, did you use the HANA version for the for BIOS or the SQL? And in one case or the other, is there any difference in the cost calculation model?
I beg your pardon, Fulvio. I didn't get the first part of the question. Did I use the
HANA version of BIOS or the MS SQL one?
Now I'm running on SQL, because this is running on my laptop.
Yeah.
But yeah, I have used the cost calculation functionality on HANA as well, and anything that I was demonstrating today, it's actually available, of course, in HANA.
Okay. Okay. Yeah. Thank you, Luigi.
No worries.
Luigi, sorry.
Yeah. Hello, Johnny.
Yeah, just the last question. Ciao. At beginning, you have created just a cost calculation with the item, the dummy item.
Yep.
And later in the sales order, have you just created or substitute the cost calculation with the new one, with the real item?
Yes.
Deleted and deleted the previous one. But what was the meaning? So, just to show the possibility to use the cost calculation with the real item.
Yeah, well, the idea.
If you have used the previous one during the work order creation, you should use the real material during the creation.
Yeah, you're right. I mean, the idea I was showing now is basically this business process where after the calculation or during the calculation, both during the sales part and during the sales offer part and sales order part, we have engineering in parallel, which is working on creating the master data and is giving us back the master data either at the sales order level or the level. But you are right. I could have left basically the calculation for the dummy item with dummy items under the product structure. And if I was trying to create a work order, the system would have warned me that, of course, some materials are not existing and I should replace them with existing master data. Otherwise, of course, the system will not do anything on those positions.
Yeah.
At the same time, as I mentioned, if you if you're not creating the master data structure with the engineering support, but you are just inserting real existing items in the cost calculation structure related to the sales order, what you can actually obtain is that you can plan with MRP directly based on the sales order calculation structure associated to your sales order line.
Okay. That's right.
So that's another option, but it depends, of course, on the business process of your potential customer.
Absolutely. Yes, also because the cost calculations is a really powerful object in there. So, you can imagine also another department like engineering department could work directly in the cost calculation.
Yeah, exactly. You got the point. That's the idea. Basically, you have some people in sales which quickly create the sales quotation with non-existing items, but they have an idea, of course, of the product, or they can be helped by engineering at the same time. And engineering is not even creating the real master data; it's just creating the product structure and for giving back the price to the salespeople. Then the salespeople close the deal, and those items, which are just an imaginary or fantasy structure at that moment, they need to become real items. Yeah. So that's the idea, to give a flexible tool for the pre-calculation, and just get to the point: is the customer wanting to buy this item for this price? Yes or no? And then we will do the rest of the work, manufacture and create everything.
Okay, thank you.
No worries. Okay. If there are no other questions, I will close. But the webinar that we have just gone through will be uploaded on our website if anybody just wants to have a look. And you have seen my email. I'll just point it out on the screen again. And if there is any question, just feel free to write me an email, and I will do my best to reply to you.
Thank you very much, Luigi.
Thank you, guys. Have a nice rest of the day.
Thanks, Luigi. Ciao.
Thank you, Luigi.
Goodbye, you all. Bye-bye.
Bye.